Today, let's talk about packages and inheritance, and let's start by first creating a new project. Let's call it YouTube Free, open it up, right-click the source folder, and this time let's create a new class, but we will actually leave the package name in there instead of just removing it like in the previous episode. Let's call it our main function. And now we are where we always were when we created a new project. However, this time you can notice that at the top of our file, we have a command saying package, and it's YouTube Free, and that is because our class main is actually contained within a YouTube Free package in the source folder. Packages are basically just separate folders for organizing your classes, and it's a really good practice to just keep using them rather than leaving everything in the source folder. At the top of each class, you have to specify which package it's coming from. In this instance, the package is YouTube Free, and if you would like to import something from another package, even if it is within the same project, you still have to import it if it's in a different package. You would go to the top of our program and simply type in import, then the name of your package, let's say metals, because we will create a metals package in a second. And then using the dot operator, you can either specify the asterisk to just import every single class from the metals package, or you could specify a precise name for a single class which you would like to import if you don't want to import the whole package. Let's leave it with an asterisk, and let's start talking about aggregation. To do that, let's first create our new package, which we already called metals. Right-click the source folder, create a new package, call it metals. Just change it to lowercase m because I forgot that the convention is to start with lowercase when naming packages. Let's change it in our import as well. And in our metals package, let's first create our new parent class, which we will then use to create subclasses of. Our first class will be called metal. As you can see at the top, it says package metals because it's in the metals package. And now let's actually give ourselves something to work with. So let's give it some variables of what metal could have and maybe some functions. As you can see, I added two private variables. First is a string storing the color of our metal. In this case, I gave it a string saying none. I also gave it an integer value, which I preset to 0. And I added three functions. The first one, which simply gets the color of our metal. The second one gets the value of our metal. And the third function, which I called what am I, simply prints to the console, I'm a metal. We can now easily go back to our main function and we can create a new metal now. And we can use all of our newly created methods. I just added a print statement to show the value and color. And also I called our metal.whatamI function. And if I run it, you can see that on our console it reads, I'm a metal, value 0 and none for the color. So now we can actually start talking about inheritance. Let's go back to our metal, and in our metals package, let's create two new classes. Let's call the first one iron, make sure it's in the metals package, and let's call the second one gold. So now we created our two new classes, and now we would like those classes to inherit everything that metal already has. To do so, we can use the keyword extends after the class name. So it would be public class iron extends, and then the name of the class which our new class extends. In this case, it's metal. Let's do the same thing for our gold, extends metal. And believe it or not, this actually already made iron and gold both be metals. And if we go back to our main, we can actually create iron as new iron and gold instance, and we can use all of the methods which are in metal. Iron.whatamI, gold.whatamI. And if I run it again, you can see that it still prints I'm a metal at the bottom. Before I go back to explain more about it, let's first clean up this area a bit, because I would like to only focus on the whatamI functions. As we already mentioned, iron and gold now are metals, which means that if you create an array of metals, it can store all three types of objects we have here. An array of metals could store generic metals, it could store iron, and it could store gold. So now let's create a metal array, type metal, let's just call the basket, and it's an array, which will be equal to all of our objects, which are metal, iron, and gold. Now, instead of calling our whatamI function 3 times, let's use a for loop for integer I equal to 0, while I is lower than the length of our basket, which you can get by basket.length method, I++. And now we can call that function 3 times in a single line simply by typing basket, giving the index I, and then calling the method whatami from it. If I run it again, the result will be no different. It says I'm a metal 3 times. However, now we will start overriding the original functions within the metal class. Let's start with our iron. We would like to override our whatami function to say I'm iron rather than just saying I'm metal. So we can do that by typing the exact same function, public void whatami, and then using system printout to say I'm iron. Let's do the same thing for gold now. But before we now run our main function again, there is one more keyword which I would like to show you, and that is @override. The @override just makes sure that the function we're typing here in the subclass is actually the exact same as in our parent metal class to avoid any mistakes. For example, if I would add a parameter to whatami of int x, as you can see, the IDE is telling me that the method whatami of type iron must override or implement a supertype method. And if I didn't actually have my @override over here, I wouldn't get any errors and the program would compile. But it's a really bad idea to do it this way, so make sure, and can result in many errors. So make sure that when you're retyping the methods to override them, you're typing them exactly as they are. Let's add override at gold as well. And now if we run our main function again, as you can see, it actually says I'm a metal, I'm iron, I'm gold, because we have overridden the whatami functions for both of those subclasses. Of course, in the subclasses, you can also add additional methods which were not present in the superclass. So for example, in our iron, I could just create a new function, which I'll call get5, and it will literally return an integer of 5. And this would work. You can add as many methods as you want to the subclasses. The same thing works for parameters. If you would like, you can add new parameters to your subclasses, for example, a string called shade, and it would all be fine. So now let's talk about the last thing, which is the keyword super. And for that purpose, I've cleaned out the functions a bit. I just left our main function only creating the new metal instance and the new iron instance. And let's first go to our metal class to create a metal constructor. Public metal. I have to use the keyword public for our constructor because the metal is in a different package, which means that if I didn't use it, our main actually wouldn't be able to access our constructor. And I would like it to take in an integer value, set our instances value to that value, and then print to console. Let's just say a metal constructor. Whenever we create the metal object, it will just set the value to whatever value we give it, and it will print metal constructor to the console. However, now we have to add a constructor to our subclass, to our iron class. So let's go to there and create public iron constructor, which will take in an integer called value. And the first thing we have to do in our subclass constructor is to use the super keyword. If you type in super, it's basically a keyword that calls the superclass's constructor. So if we're here in our public iron, the super keyword is actually a method call to our public metal. But as you can see, it highlights an error because we actually have to give it an integer value because the super constructor takes in an integer value. So we will be giving it the value we get. Let's go to our main function. Let's give metal 5 and iron 7. And if we run it now, you can see it prints metal constructor twice to the console. However, what's important to note is that now after we've done this constructor in our subclass, we can actually expand on it, and below the super command, we can do whatever we want, and we can make that constructor do more things than it was doing in the superclass. For example, print out some text. I will print out iron constructor, and if I run our main function again, as you can see, it says metal constructor twice, and then it calls iron constructor. Thank you very much for watching. I hope you enjoyed, and I hope I'll see you in the next one.